Thank you very much. I'm very honored to be here. I'm very honored to give this lecture in the memory of Rein, who actually invited me pretty early in his path with GPS tracking data, and we have collaborated ever since, not as intensely as we probably both hoped, or the groups both hoped, but we did. Now, I have to admit that I was a typical professor and I didn't read my instructions properly, so I have too many slides, so I will skip through some of them and focus on those which are most interesting. So the question is, and that was Rein's insight, that GPS data give you an idea of where people are and how often they are there. And that links very well to a long-established idea in geography of the activity space, of that part of the world where a person lives and acts. And for the first time, the GSM data gives you an idea to truly capture that. And I'll talk later about the difficulty of doing that. Now, I have to also say that I kind of focus a bit in this and say, okay, let's look at what GSM, what GPS data can give us and what is missing. Because while they are great data sources, they are not complete. And so we have to ask, how can we capture other things which are of importance? And before I get there to the microscopic human scale, I want to look at the large scale, because obviously people act within their possibilities, what society provides for them through investment in infrastructure and services. And a very good example of what we have achieved, and what also now creates problems, is what happened in Switzerland. This is Switzerland in 1950. If you take the travel times from each municipality to every other municipality and rescale the map to be readable in travel time. Now, for those of you who know the geography of Switzerland a bit better, know that this is distorted. This is not providing the same speed in every direction, and the scale and shape of the squares also show you. So, particularly the southern parts of the country were farther away from the center than the other parts. Now, 1950, but that's of interest, but of real interest is to compare it with 2000. This is the same approach, the same data, the same way of calculating this. And you can see that the country effectively shrunk itself in half. And I would argue that this is true for all of the industrialized world. So we were extremely successful in providing larger accessibility to our societies. And this success is still in the mind of everybody, both the citizens and its politicians. They still think we can continue along that line, we can continue to shrink the country. Now, we have done that, and we have done that in particular because we built motorways. And I was really pleased to travel on the motorway at least halfway to Tartu yesterday from the airport. And everybody has these images of this type of road, elegantly aligned, empty, and in sunshine, which was true yesterday. But we know that this isn't true all the time. This is true only in exceptional situations. Today, around the major cities, motorways are neither well-maintained nor empty. So they're a source of unreliability and not of this glorious feeling of, oh, let's travel in the sunshine. But the problem is that it's still in the back of everybody's mind, and nobody wants to admit the reality. And that provides us with the dilemma which transport planning has at this moment. And I want to highlight, before I go into the data collection, to remind us that the data should help us in the policy making to overcome this dilemma. And the dilemma is that we know by now that accessibility, i.e., being able to reach many more locations and people at higher speeds, increases productivity in the economic sense. And that's not as well documented, but it stands to reason it improves our social capital, our ability to maintain the local connections with other people. And I'm pretty sure that the airport in Tartu is justified on that grounds, that it kind of allows to link Tartu with the rest of the world. Now, while we did this since the 50s, and maybe in some countries since the 30s, we have become aware that this higher accessibility has all kinds of downsides which are now binding us. They're providing the constraints for our further action. Obviously, when you build those roads, people will buy the cars to use them. Okay, that's really their purpose, for people to use them. They will increase travel demand. They will produce true induced demand, more what happened. And as long as we are driving ICE cars, they produce greenhouse gas emissions, and even with electric cars, we produce greenhouse gas emissions embedded in the vehicles themselves. And because we are changing our behavior quicker than we are able to build the roads, we get congestion, which is the downside of them, and that's why they are getting out of favor with the locals. In addition, it encourages working from home, which on the one side is nice, although the downsides of working from home are becoming ever clearer. They're also putting a death nail in what's left of public transport, because people who have cars and don't need to go to the office 5 times a day are even less likely to use public transport than before. And finally, it invites sprawl. Now, the farmers are happy because that provides them a big payout when they sell their land, but it's not really what we want. Now, this dilemma is unsolved, and I'm not going to talk about possible solutions today, but maybe in the discussions we come to that. Now, activity space. Now, I said this is a long-established idea that we have this part of the world which people use. Now, the activity space is not normally theorized about how it is created by the people and how it might change. And I want to show you one way of thinking about human travel behavior which gives us its natural dynamics. When you think about activity space, it's a product, as I said. And how do we think about how people behave? I think we assume that physiological needs. They need to eat, they need to sleep. They have commitments. They have entered work, social commitments to friends, family, clubs, whatever. They have desires. For example, they might want to see Bali before they die, so they will travel to Bali at some point. And finally, they have things which they didn't do yesterday, which still needs to be done. That becomes their activity repertoire. That's the things they want to do. And compare it against what they currently need to do. Activity repertoire is all the places they know where they could go. Now, the repertoire isn't necessarily coherent spatially, because they might have places they want to go, know they can go, where in Tallinn, but Tallinn isn't coherent with Tartu. So we'll have definitional questions come up here on the activity space. Then, given that what they know they can do and where they can do, the activity repertoire, they have to combine with what they want to do. They get a daily activity calendar. What do you really want to do today? And in this case, we are already making a pretty big assumption that you already know at the beginning of the day what you're going to do during the day, which is completely unproven and very unlikely to be true. But anyway, for modeling purposes, we make that assumption, and then we have some mechanism to schedule, i.e. optimally place those activities into an order, and we have an activity schedule, which we can then execute. And that interacts with the networks on which it happens, with the opportunity in which they could realize that, which are based on the mental map which people have. Now, life isn't perfect, so the schedule will not work as planned. So you will have to reschedule, you have to execute it differently, and you will learn new things, you will certain things which can't happen, so there are things you have left, things you didn't do, and you will update your mental maps, your activity repertoire, because, for example, for me, if I'm going to be taken to dinner tonight into a restaurant I have never been before, that adds to my activity repertoire for my next visit to Tartu, which might or might not happen. Now, here you have the dynamics which we can think of, and of which most of them haven't really properly studied. So there's a lot to be done if we wanted to take this framework and make it actually work for us. But in thinking, it already works. Now, if we take this as the background, what do we then get? So what is then the current activity space? Because the activity space was different 5 years ago and will be different in 5 years' time. So to simplify things, and because we like to measure things, we say the activity space is the activity repertoire locations between time t and minus delta t. So we give it a time space already. And that's obviously a question: 1 year, 5 years, 10 years. Now, if you take this definition, we can start measuring it, because the repertoire becomes visible in those activities which people use. But then there's plenty of questions, and that's why the literature on activity spaces is so disjointed and slightly incoherent. You measure it only for one person, okay? Or do you measure it for a group of people you believe are similar? Assumptions. How do you fix the delta? Do you say, okay, just 1 year, 5 years, just 2 weeks? How well are the observed locations capture the repertoire? We only see what we see. We don't know what the person knew about. Is any XY you observe truly location? Now, in places like Tartu and maybe Sweden and other places, you might say, because most buildings are single purpose. But if you go to a place like Singapore or Hong Kong, an XY location doesn't tell you anything, because in that high-rise, there might be 50 different firms and 50 different activities you could do. So you have a problem. And then have the people different activity repertoires and activity spaces. For example, is it worthwhile to think, for example, for me, of my activity space I have in Zurich, the activity space I have in Innsbruck, or the activity space I had in London, the activity space where I lived, or is it all just one big thing? And the literature is quiet on that front. And then, how quickly do we change? How quickly do we learn new things and update this? And there has been some work on this, but not as much as one would hope. And then, do we aggregate different persons together? Maybe we should, maybe we have to, because we have only 1 day data, which is too short. And finally, how do we capture the mental map? I don't really want to talk about the mental map. The geographers in this room know much, much more about this and how to capture this. All I can say that it's next to impossible to capture, but I'm happy to be corrected by the people who know more about this. So these are all the factual and detailed questions you have to do and you have to solve and address in your study. You will not solve them, you will just make a fiat and say, okay, this is what I'm going to do because this is how much money I have. Now, and then what are we doing? So principally, we'd say, okay, all the spaces we observe is the activity space. So we ignore the repertoire, full stop. And then we summarize it. And there again, you have different options you can do, and that's why the literature is so incoherent, because you might say, okay, it's the activity ellipse, i.e. the 95% confidence interval around the mean location, the median location, the home location. And all three will give you different numbers and different results. So you have to be careful when you read the paper. And finally, you can do some convex hull of whatever property you like to have. And then you have to decide what data stream you use. Now, as we learned, Rein obviously favored GSM, and I'll come back to that, i.e. mobile phone data. Other people would say, okay, GPS is actually better because it isn't cut off at the national boundaries as GSM data normally is. And my slide now has disappeared. And finally, you use a diary. There were people in the past who did these things, and in the longest one, I was able to lead a study where we got people to report 6 weeks of their daily life. And there were others who did even longer studies. So you can do it traditionally as well. But nobody does that anymore because most students only look back 10 years in the literature research and all travel diaries have disappeared. So the whole idea has disappeared unless Harvey reminds them because he's too old to have forgotten them. Now, okay, given that my time will be a bit tight, I will just talk and now skip over some of the slides. I truly apologize for this. Now, obviously, GSM is a primary source because it gives you humongous amounts of data if you can get behind the Chinese wall of the operator, which some people are able to. And that's one big thing which Rein did, because not only did he come up with the idea, but he set up a firm to do the hard work behind the Chinese wall. And I'll come back to that towards the close. Now, the GSM data are obviously very advisable because they give you, when you get them, enormous sample sizes. You get now enormous numbers of locations, because when we started, the GSM data only located or gave you a track when you changed the cell of the GSM system. Now, maybe 10, 15 locations per day. Now you get thousands. So GSM has changed in its nature. So that's fantastic. And if you work behind the Chinese wall, you have all that detail. But that Chinese wall is a big hurdle, which only few academics are willing to break, and all the more power to Rein of having done that. Obviously, certain downsides to GSM. There's no personal details. There is no purpose and stage identification in the data. The purpose and mode has to be imputed, obviously with error. And finally, you don't know how unbiased the sample is. Obviously, people do a lot of work on this, but I'm not sure whether they truly conquer that problem. And finally, how long will the observation period be? Now, when Rein started, the GSM data was available for years. So you get, for one person, a year's worth of GSM data. The European Union has stopped this, and I think it's now 5-6 years ago, the GSM data provider have to rehash the data so you only get 1 day at a time. So GSM data is still enormous, but not as useful for the research questions we have, like the activity space and other issues, as it used to be. There might be countries where that's not true, but in Europe, that's a big limitation we have. I think I'll mostly skip. I wanted to report on a thesis which was done by Maxime Janssen at my chair, who had access, together with colleagues at Orange in France, of 6 months worth of GSM data, which was collected just before the European Union regulations came in. And that data set was obviously grandiose, because 6 months of data, and a big country like France, so we could actually see something. I have to apologize, 6 months in Estonia wouldn't tell you much. It's the same thing that 6 months in Switzerland wouldn't tell you much, because you're out of the country kind of before you stumble. And anyway, so what did he do? What were we interested in? We were interested in long-distance travel. And I want to show you one key result, which is very important because it's one of the most crucial in the context of global warming. How many long trips do we do? Because to much of the despair of people who are eco-conscious and cycle at home, the moment they get into a plane, all of those gains are gone. The moment they've gone to Bali, all of those gains have gone for 10 years of their life. Anyway, in France, which is a big country, you can capture long-distance travel quite properly. And the one thing which was crucial here is that mobile share statistics at the fourth column. It showed us that nearly 60% of the French users of Orange had about 1/3 of the market in France, had nearly 60% of them did at least one journey longer than, I think, 75 kilometers. Now, if you look at the French national statistics, and they did surveys, there the share was only 25 or 50%. So these data sources systematically underestimated the amount of long-distance travel. Now, in Estonia, I would argue that the GSM data still gives you a good idea, but you might underestimate all of the out-of-country travel. It's certainly true in Switzerland because, as I said, you're out of the country before you stumble. So you really have to have other data sources, and GPS is that other data source or a diary. Now let me skip over his work on trip purpose imputation other than saying that he did do that. And in the end, this is the pattern of the amount of long-distance travel, mostly for leisure. And you can see that the other sources systematically underestimated the amount of long-distance travel, and with that, obviously, the amount of CO2 emissions which the French produced, and massively so. Now, let's talk about a second data source. Let's talk about GPS. GPS obviously came in before, but it became extremely powerful the moment everybody had a smartphone. It started about 2007 when the iPhone came up, and ever since we are continuously tracked by the people who claim to give us free services. And I think everybody in the room knows that any free service you subscribe to on the internet tracks you. And that's part of the deal. If you might know it, you might not know it. That data is sold by various data providers of various different qualities. But it also gives us a chance as academics, as researchers, to install dedicated apps to track and trace people. And there is a large number of colleagues who are doing this work. It is just extremely painful because the owners of those smartphones, i.e. their producers, change the operating systems every 5 minutes, and your code will die. So if you do that as an academic, I admire your braveness, but say, okay, why is he doing this to him or herself? Anyway, so what do we have there? We do this with GSM data because GPS data because there's decreasing response rates to diaries. There is limited observation periods with diaries, but unlimited observation periods with GPS data. Once you get that app on somebody's phone, you're good. And the precision of the diaries is limited, both in time and in location. So they are not really that, they're a good data source, but not perfect. And then GPS and other sensors are on the phone, so you can not only measure where they are, you can measure the loudness around them, you might measure all kinds of things. So you get a pretty complete picture of the life of that person once you have a sensor on the phone. You have OSM maps, which obviously is a big improvement since the time Rein started. You have now nearly complete maps for just about everywhere in the world, which allow you to geolocate your GPS points. You have improved stage detection. The people who write these systems are now pretty aware that they need to divide up the stream of movement into stages and trips, and the software has become pretty good at that. You have much improved machine learning approaches to impute purpose and mode. And finally, you can do recruitment and debriefing surveys, so you can ask more questions, which, for example, GSM studies don't allow you. And finally, the downsides: you have to pay for this, you have to do the recruitment, and you have to validate, or the respondents have to validate what you find out, which actually makes it a pretty substantial response burden. I'll come to that. I'll talk about one study because it's one of the bigger ones. Together with colleagues from the University of Basel, we did a virtual road pricing, mobility pricing, random control trial in Switzerland. And these are the colleagues which worked with us and with me. And one of the key things which we did was to do this for a very long time. What happened was that the actual study started in fall 19, and the very last participants in the study were just finishing when COVID came to Europe. And I was able to override the objections of the university and begged those people who had participated, nearly 3,500 people, to continue to allow us to track the impact of the pandemic on travel behavior. We did this, and we provided those data into the planning and the response of the country to the pandemic. Now, what you see here is what share of people were out of the home during those years. And you can see quite clearly the breakdown of the lockdown, which is the red line in the first year, when Switzerland imposed a pretty lenient lockdown, nothing like in France or Spain, but still, it came down and recovered very quickly. And the yellow and the blue lines are the second and third year. And you can see that there was a consistent change in behavior. I think we tested statistically that the share of people out of home went down, which is the result of working from home. About 5 to 6% people less go out of the house. And the second thing you can see quite easily is that the Swiss ignored the impact of the pandemic. This is the dots at the bottom. This is the share of people in hospital at the time. The Swiss didn't care. And I guess that was true in all the countries where the lockdowns and restrictions were relatively lenient, and maybe the public not as panicky as elsewhere. So that's the first insight we got from that study. The second is on the activity spaces, which are the blue lines, if I remember right. Yes, the red lines. This is the activity spaces we observed, and this is the activity ellipse, 95% activity ellipse around the home location of the person. The home location. And you could see that those red work days and non-work days varies enormously, and it has a strong seasonality, which comes as no surprise for somebody living in Estonia, that people behave differently in summer and winter. In addition, you can see on the blue line the number of trips the persons did during one day, and again, you can see the seasonality. It's not quite as strong, but it's there as well. And obviously, the number of trips are higher than you normally get reported in a trip diary. So the question now, coming back to my original questions, how do you, in a study you want to do yourself, which period are you going to pick? How long are you going to observe when you do a travel diary, a written diary, or if you do a GSM study? How many weeks do you want to capture? Because depending, you get different results. So if I were you, and if you're going to do this, try to do at least a one-year study so you get an idea of the seasonality and the variance. Now, I wanted to talk about participation in the study, and that's the next topic. This shows you how strongly people participated in the MOBIS study. We renamed it MOBIS COVID after we invited people back in. And you can see at the left side, this is the participants in the original study. In this original study, we invited people in for 8 weeks at a time. So you get a peak, and then you get a reduction as planned. And then you get the new peak when we invited people back in. And this was an enormously positive response by the respondents, because they were also interested to find out what was happening to them and their society at that time. But you have to validate the data. You have to ask them, okay, did we do the right thing with our instruments, kind of converting the stream of GPS points into stages and trips? Did we guess right when we guessed the mode or the purpose? And that's hard work, because that's about 5 to 10 minutes every evening, and people get tired of it. And so you get the reduction as you would expect. And that's what we saw. So you can do these studies, but you have to remember people get tired of the workload. Now, in the original study, we paid them 100 francs for their participation, so that was quite a lot of money, but we couldn't do that in the MOBIS part of it. But still, They were great participants. We have this data is still available, and we share it with others who want to use it. It's an enormous amount of data if you're interested in that. And I can tell you, there's plenty of other data in Switzerland, so you can do lots of nice things with it. Now, the next question is, how many people did we have to talk to win the original participants? Now, I do know that most academics don't want to get their hands dirty these days. So they just buy the respondents from panels, which is obviously nice, relatively cheap, but you have no clue who you have. Now, those panel providers tell you that they are perfect, the next best thing to sliced bread, but you're allowed to have doubts. Now, what you see here are the statistics about the recruiting success or non-success. In this original study, we sent letters to 90,000 people, which is a big budget post, and you have to budget for it. And then how many participated in the introductory survey, and on, and how many people at the very end finished. And in this study, at the very end, we got a 4% participation rate, which obviously will get your colleagues in statistics gray hair, because they will say, this is not a random sample anymore, all the stats you do is going to be wrong, so start again. Now, as engineers, we ignore those and just do what we have always done, which is probably not the right way of doing it, but that's why engineers don't get Nobel Prizes. Now, one other thing, though, is that once they have started, they will stick with you. So it's worth investing in those people, but you have to be very robust and not despair when you get those numbers. Now, to show you that this obviously is also a function of how long you want to keep them in the study, because the original recruitment was for an 8-week study, so it's a long commitment. This is the red dot at the right end of the scale. And you can see that if you kind of step back and say, okay, maybe just 1 day, maybe 7 days, you get higher response rates, participation rates, but after that it drops. Which obviously tells you what you can do and what you can't do, and why you maybe just buy the data from somebody who has stolen it from somewhere, not stolen, but acquired it some way or another from somebody else. But then you don't have a chance to do recruitment or debriefing interviews, so you know very little about these people. And obviously it always helps if you promise money or an incentive in one way or another. Now, then there's a couple of other issues which you have to worry about. One is that the different machines, different phones, have different qualities, and this has been shown consistently that the interfaces you implement on the iOS are more friendly than the interfaces you implement on Android, and people respond by quitting earlier and quicker. And here I just want to go then to one element, one study we were able to do. Over the 25 years of my time at ETH, we did about 70, 80 studies, surveys in one form or another. And that allowed us to think about what causes this response we see. And at the very last PhD student who analyzed it, Daniel Heimgartner, did this. And by that time, we were able to distinguish the studies whether we had promised an incentive or not, whether we had recruited them in another study or not, just a cold call. And if you look at this response rate as a function of the response burden, you need a measure of response burden. And we had adapted and improved on a scale which had been developed by a market research firm which used it for calculating and budgeting its own studies. And that's on the x-axis. And what you can see here is that when you have studies, which is the blue line, where you do your own recruiting and you have an incentive, and if the study is in addition maybe interesting, you get reasonably high responses. But if you're just cold calling on people, any question you ask reduces the response rate. And it's in this set of lines in which we act. Now, obviously, this is just one institute, just one particular academic field. It would be most interesting if other academics came together and repeated this analysis of their response rates. But I'm pretty sure that the tendency will be the same. Every question you ask is a certain share of respondents fewer. So, why is that? One is, for the respondents, is how easy is the survey, the tool to use? How much effort are you asking them? How many questions? How difficult are the questions? How much effort do they have in a recall? Is the topic relevant to them or not? Is there an incentive or not? And do they have actually the time to do it? Because it takes them 10, 15 minutes. So do they have that in their busy day? Because of these questions, in the studies of the IVT, we generally got highly educated males with relatively high incomes, and generally they had a season ticket, i.e. they loved public transport. Okay, this is the bias we knew and the bias we could correct for. But obviously, there are some gains of asking people for a long time, observing them for a long time. In the Movis COVID data, we had observed people up to 300 days. And if you look at the quality and the precision of your imputation results, it improves with every day you get. And these are the different lines I show here, that every additional day you have observations from the respondents improves your observations. And so it's no surprise that when you have a one-day GSM study or a two-day GPS study, your trip, mode, and purpose imputation will be not as good as it could be. And you have to acknowledge that. Now, I think I will skip over this. I only want to say that we want to know more things. And ideally, we want to know expenditures. We want to know about the social network. We want to know many other things. But because we are too nosy, it's going to be difficult to get all those. Having said that, we did one study where we actually went that way, and I can talk more about this if you wish, but I now want to talk about something else. And I think I want to talk about something else because it highlights how special Rein was in the work he did. The issue is that when you come up with a new idea, like Rein did, why can't we use all of that GSM data for geography? And how then can we make use of that data to influence policy? Because Rein, in the end, was more than just an academic geographer. He wanted to impact society, and Estland in particular. That's not true for every academic. Some academics are happy with their paper, and that's it, and then their life ends. But for those who want to do a bit more, life doesn't end there. And I want to talk about that, and I want to talk about this with this little table, because they highlight the different roles which we have or could take. The first thing is you have an idea, which is fine. And very likely, this very first idea gets then translated into some prototype for, I think, with Andres, we have somebody who likes to build physical models, so he would build one physical model of this. Or those more on the engineering side, they will build code. Okay, this is fine and gets that person a PhD. But the code this person has written is essentially unusable for anything else but giving him or her a PhD. Because the student doesn't care about the niceties of programming, how stable it is, and that he actually really got all the bugs out of the codes. Why should he? He just has to convince the reviewers and his supervisor. Now, it changes when that prototype wants to be moved into use. And that's one thing which Rein obviously did do by setting up Positum, the firm which wasn't mentioned before, but he set up a firm to commercialize his idea and his insights. And I think that's an important next step you can do. Now, the academics who don't want to leave the ivory tower maybe just support the startup, maybe they get engaged in it. And then suddenly, that code becomes professional. So some software engineer takes it, maybe in a physical sense, some factory will start building the object which you have come up with. Now, this is nice, and if you have the funding for it, it's great, but that's no sale. That doesn't have an impact in the real world yet. So you need to transmit it into practice. And that's where Rein also got involved, because he acted as a consultant to the public. And that's where most academics then say definitely no, because they have to handle with people who can't cope with academics, so they can't cope with people who can't cope with academics, so they say no, thank you. So you need to find a consultant who takes on the product to make it work in the real world, to earn money with it. Or you need a firm to do the same. Now, this is nice if you have a consultant who can then say, okay, I have this marvelous tool which is much cheaper than doing in-person travel diary survey. I can now have data from X million people, and then starts to trade in this. But even then, the consultant, will have to overcome or win a position which is called the filter, because the public and public administrations have specialists who act as in-house consultants and advisors, and you have to win over those advisors, because these advisors sit on the budgets, they sit on the committees, which says, yes, we can trust this data. Oh yes, they have done enough to correct the biases inherent in GSM samples. Now, that advisor will work directly with the executive of that town or that region. Because those executives, normally elected politicians, don't have the time to think about the details of the technology and where the data comes from. They will trust him or her. Now, if the executive is then indeed convinced that this data source gives you information about the problems you have, you can go to the sovereign. Now, in Switzerland, that would be winning a vote based on your data that something has to happen. A vote in a referendum, which happens 4 times a year in Switzerland. And that means that you have built up enough trust from the first idea till your product and your policy suggestions. And I think this is where Rein also got engaged in trying to move his results into policy. And I think that makes him outstanding, because very few academics are willing or able to cover the whole range of tasks involved in that scheme. And I think in that spirit, I say thank you again for having been invited. And if you want more questions and search for more publications, here you go.
Okay, we have time for some questions. Let me start off with one.
Please.
You mentioned that participation is a function of how interesting the study is and whether people are engaged in the topic.
Yeah.
Are you not affecting the behavior when you're revealing that much to your participants? Say if you're doing a study of physical activity, then people get competitive. Those are the ones who want to participate, and they change their behavior in order to hit the metrics. How do you respond to that?
I think that's a fair point. In this, for example, in the RCT, I reported the MOBIS RCT, we never told the respondents that it's going to be a random controlled trial of mobility pricing. Mm-hmm. We recruited them for a mobility study. And yes, you will get more likely people who are already mobile, fair enough, and that's true for all mobility studies. None of them escapes this trap. But you can minimize it by the incentive, by making it as easy as possible. And one thing which is important, by providing constant feedback to them so that they see that the team is truly interested in them.
Mm-hmm. Now, what about socioeconomic differences in participation? I mean, one of the things we try to do in transportation is not just meet a mass market, but to be inclusive and provide mobility to as many and accessibility.
I think in our study, we were pretty good across the board. In terms of, we captured all income bands pretty well. Yes, we had a bias to wealthier and more higher educated people, but it wasn't at the complete expense of the uneducated and poor.
Mm-hmm. And just one more question, and I'll see if the audience has some questions too. You know, journals are increasingly requiring you to submit code and data to get papers published.
Okay.
And, you know, what's your reaction to that? Because you just said earlier that these studies can't be repeated, that they become the code becomes specialized for the study and not general unless you take it commercial. So
I think it's a fair thing for the journals to do.
Mm-hmm.
One can ask whether the reviewers are actually able to do anything with it, but that's a different question. And I have always made my data available, as you might know, from the very start, from that 6-week diary study I mentioned. That data set has been made available. Now, there's obviously questions. Did I protect the privacy of those people? Maybe strong enough? Maybe not. But yes, it's perfectly fine to make the data available. I think we should, but we shouldn't hope that this solves all the problems we have.
Questions from the audience, please?
There is a mic already.
Okay.
Great.
Hello,
Yes.
Carl Samuelsson from University of Gävle in Sweden.
Yeah.
Thanks for a very nice presentation. I was thinking about the time delta of activity-based studies,
Yeah.
and another parameter maybe, which is the sampling frequency. On one end, if you have just one location, maybe the home location, that's like the minimum.
Yeah.
But then you can go up to like 1 sample per second even
Yeah.
with GPS data. So just curious to hear how you think about how those two interact, depending also on the research question.
Okay, fair point. Now, having had the data, we looked at the rate of innovation, which you can see. And there's constant churn in the locations which people visit. On average, what was it? About 20% are new every week, because you go to a place you haven't been before, which then tells you, how many locations do I need? If you make a simple calculation, say, okay, 4 trips a day, maybe that's 3 trips or 2.5 trips to a location not home. Over a week, that gets you about 20. So we need 20 locations in a week to get a first idea. But given the churn, you probably want to ask for 30 or 40 locations. And if you do it by randomly probing your respondents, that becomes obviously tricky, because you will meet them again and again at certain locations. So you need a relatively sophisticated sampling scheme to maximize the new location, the different locations you want to get. Yes, that's a way of doing it. I personally would prefer just a constant observation because of all the other gains you have from that. But it's certainly a valid alternative approach.
Thank you.
Other questions?
Yes.
Thank you, Professor Axhausen, for your sharing. And then I actually have one question. They might be a little bit too naive, but what we can observe from data is actually an outcome. And then when people are making decisions, it's actually more like a process. And then given nowadays our society is more complicated, for example, being immobile, it doesn't mean I'm not getting to any activity destinations because there are some virtual services that came to me.
Yeah.
And I was wondering from whether you have any insight or any inspiration that we can understand the process better instead of like outcome.
That's a good point. There's various ways of thinking about that. One is obviously on the transport domain to change from a focus on movement to a focus on activity. Essentially, enriching activity diaries with location information, because the classical activity diary studies are very poor at their localization. In this study, which I couldn't get into, Time Use Plus, we combined a GPS tracking with a time use diary. So we knew what they were doing at home or at the location. Now, that's still not answering your question about the process of the decision making. That is an enormous challenge because you, in principle, would have to ask the people explicitly in qualitative interviews how you came up with those choices. Okay, economists, psychologists, and transport people love their stated preference studies, which is at least one way of touching on this, but it's obviously not really answering the question you raised about the process. So there's new work, other work you could do on getting to the process. And the time use gives you one view on it, the SP study, say preference studies, give you another view, but you probably need to do even more detailed questioning of the respondents to get at what actually drove them to make the choice.
We have a question down here.
Hi there, Kai. Thanks for a great talk. I've got a question that links to a conversation we were having over lunch and also links really well to your point about PhD students potentially generating spaghetti code, for want of a better word. And I agree, there's a massive problem there. That's like, there's a bottleneck between getting amazing research and papers into production, as you put it. And we made the point that if you're a PhD student, as some people in this room are, imagine you've got like a good first paper, you get it published in a top journal, and you want to make change happen. And I think that's often the case. I think a logical next step would be, now I want to productionize this, I want to make a web application. And with AI, you can actually do that quite quickly. But I imagine the reaction of many professors would be like, no, you need to start working on paper 2 now. So could making a web app or some kind of product be as valuable as an academic paper? Could that help overcome this issue?
I think that's a good idea. For example, I mentioned Daniel Heimgartner. He did this analysis of the response rate, but he also took code which had been developed by a PhD student of Pat Mokhtarian and turned it into an R code, which is now published online. And so nobody can say that these types of methods are difficult to apply these days. But he put quite a lot of effort in to make this nice and clean. The challenge is, yes, it's a good idea, but I would argue that most supervisors can't see the difference. Because if the student just hides the spaghetti code behind a web interface, that doesn't really help. Because you have to make the code more stable. So the supervisor would have to impose lots of testing routines, and would have to start thinking about those testing routines, which is probably nothing which the supervisor normally does. So yes, it's a good idea. Yes, the student gets credit, but we would have to find a mechanism by which we can then ascertain the quality of what happens behind the pretty pictures on the web.
I think we're out of time, but I want to maybe end with an existential question.
Please.
So you talked about activity spaces, and you mentioned things like ellipses,
Yeah.
and convex holes, which are very simple representations of activity spaces. Now we know a lot more about mobility. Is the activity space concept still valid, or how do we evolve that at this point, given what we know about mobility?
I think it's still a useful idea if you talk about everyday life, because it gives you a pretty good idea of the scope of how far people are. And if you want to compare different groups of people, you will see the difference there. I think it's a very good first summary you can do of the data. Is it complete? No, it isn't. Should we do more? Yes, we should, but it's a very good start.
Okay, we'll see we're out of time, so I think we'll join me in thanking Professor Axhausen for a wonderful opening keynote.